viewers, here we are going to study about internal resistance of a cell. Internal resistance in the sense you can consider a cell here. I have taken a small cell which will be used for remote of AC. Okay, you can able to see here there is a positive and the negative terminal will be shown in this. Based upon this, I have drawn the small diagram here. The positive and negative terminals has been shown here. The positive terminal means the particular lid will be coming out, and the negative terminal will be a flat surface. You know that in a particular circuit, when I am connecting a cell, what will happen? The positive terminal, from the positive terminal, the electric current will start and it will be flowing in the circuit and will reach the negative terminal. Similarly, but after reaching the negative terminal, the current has to flow inside the battery from negative terminal to the positive terminal. So in that time, the resistance offered by that battery, we are calling it as internal resistance of a cell. Okay, so when the particular resistance offered by the cell to the current flow is called as internal resistance when it is flowing inside the battery. Okay, so very important, the internal resistance depends upon the distance between the plates. Okay, that means when the distance between the plates are more, the current has to flow for larger distance, so length is increases, that's why the resistance also increases. The next one, it depends upon the concentration of electrolyte. That means if the concentration of electrolyte is more, then electrons cannot able to move freely, so that the particular resistance will be increases with respect to what? The concentration. That's what R is directly proportional to M. Then area of the plates. You know that whenever the area increases, the resistance will decrease. Similarly, here area is inversely proportional to resistor, or resistance is inversely proportional to area. Then the nature of the electrolyte and electrodes used, because the resistance can be varied for the different electrolytes and electrodes. So based upon that, I can able to say that the nature of the electrolytes or electrode also is determining the internal resistance of a cell. You can compare these two here. What you will get? In the case of a cell, the resistance has been connected, that actually the electrolyte is presented inside, so I have drawn, it's nothing but a resistance. When I am drawing like a circuit, I can able to write that internal resistance will be in series with the particular cell what I am connecting. Now here we are going to find out the terminal potential difference of a cell. Okay, for that purpose I can able to consider I is equal to E divided by R plus R. You can able to consider what? I is equal to E divided by R plus R. That's nothing but this is my circuit. The battery is supplying the EMF of E. So IR into IR. Otherwise you can able to take it as what? R and R is nothing but total resistance, because it is connected in series. That's what total EMF divided by total resistance will give the value of total current. Then I can able to multiply this. So when you are doing cross multiplication, we can get E is equal to IR plus small I into capital R. Here V is equal to I into R, that is nothing but potential drop across the external resistance R, that is nothing but potential difference of the cell. Similarly, I can able to write in this equation, if I change it, instead of IR I am writing V. So you will be getting E is equal to V plus IR. Then what is V? V is equal to E minus IR in the case of discharging. Similarly, V is equal to V is equal to E plus IR in the case of what? Charging. That means charging is nothing but when I am giving the potential supply, potential from the outside. So in that case, charging will be equal to internal drop across the internal resistance plus the EMF. Okay, so when I am giving some kind of supply, first it will be supplied to satisfy the potential drop, remaining will be stored as what? E. That's what V is equal to E plus IR. Okay, so there are two formulas, that is V is equal to E minus IR for discharging. So suppose I am going to use my mobile, that's called as discharging. That time I can able to get this. Suppose I am going to put charge for my mobile, so charging condition V is equal to E plus IR we can take. Now the next one, internal resistance. Okay, internal resistance in the sense I am going to measure like this from here. If you change the equation, you will be getting that like this, that is E minus V divided by I. I can able to write I is equal to what? V by R. So I can able to substitute here R is equal to E minus V by V into capital R. So R is equal to, if you split the numerator into two parts, E by V minus V by V, V by V is equal to 1. So E by V minus 1 into R. Special case, when the cell is delivering no current, actually if the particular circuit is not connected with anything, then open circuit. Okay, then I is equal to 0, so we can able to get E is equal to V or V is equal to E when there is no current, because there is no current means there is no internal drop across the internal resistance. Actually this concept is very important, because this concept will be playing a very important role in the case of combination of cells. So study well. Thank you.